Unlock the secrets of longevity with scientifically proven anti-aging strategies. In this video, we explore how to naturally slow down aging, improve cellular health, and boost energy and cognitive clarity at any age. Learn from Japanese centenarians, groundbreaking research, and practical lifestyle habits that anyone can adopt. Discover the power of autophagy, MTOR, AMPK, Sirtuins, green tea, fermented foods, intermittent fasting, mindful eating, and morning rituals that enhance longevity. Whether you want to add years to your life or life to your years, this video provides a roadmap to living longer, healthier, and more vibrant. Start your journey to empowered, science-backed aging today.
Part 1. The Origins of Autophagy and Japanese Lifestyle. In 1988, a curious Japanese scientist named Yoshori Osumi peered through a microscope at simple yeast cells, unaware that he was on the verge of uncovering one of the most transformative secrets in human longevity. While observing these tiny organisms, he noticed a remarkable process: cells literally consuming and recycling their own components to survive. Little did he know, thousands of miles away, centenarians in Okinawa were living daily routines that unknowingly mirrored this same cellular mechanism. These elders, celebrated for their extraordinary lifespans, practiced simple, centuries-old habits that maintained vitality, mental clarity, and resilience. At first glance, their lifestyle seemed unremarkable: light breakfasts, portion-controlled meals, and frequent movement. But behind these rituals lay the activation of autophagy, your body's most powerful anti-aging process. Autophagy, derived from Greek words meaning self-eating, acts as a cellular cleanup system, removing damaged proteins, worn-out organelles, and toxins, while recycling useful materials to maintain cellular health. Research from Nature Aging shows that individuals with the highest autophagy activity live an average of 7 years longer than those with the lowest, and predictably, the Japanese consistently rank at the top. To understand this connection, imagine your cells as miniature cities. Every second, they produce energy, construct structures, and accumulate waste. Without an effective cleanup system, toxic debris would pile up, compromising the entire network. Autophagy functions as the city's waste management service, removing damaged components, restoring order, and even making cells function younger and more efficiently. Yet the story goes beyond laboratories. While Western science spent decades trying to artificially trigger autophagy, Okinawans achieved it naturally through daily life. Early morning sunlight, mindful movement, moderate meals, and fermented foods created optimal conditions for cellular renewal. Research published in the Journal of Clinical Investigation confirms that maintaining active autophagy pathways correlates not only with longevity, but with preserved cognitive function, physical strength, and immunity even past age 90. This extraordinary alignment between ancient wisdom and modern science challenges the idea that aging is inevitable. By observing these Japanese practices, researchers found that longevity is influenced less by exotic superfoods or advanced medicine and more by consistent, intentional habits. From the one soup, three dishes approach to early dinners and natural fasting periods, these routines provided a metabolic environment in which autophagy thrived. But the magic didn't stop at diet. Social rituals, sharing meals, eating slowly, and focusing on food without distractions enhanced digestion and regulated metabolism, reinforcing the natural activation of cellular cleanup mechanisms. Green tea, rich in epigallocatechin gallate, or EGGC, further stimulated autophagy, while fermented soy, natto, seaweed, shiitake mushrooms, and fatty fish provided compounds that enhanced cellular health and repair. Even subtle practices, like eating until 80% full, or harahachi-bu, created sustainable calorie restriction that naturally triggered autophagy without stress or deprivation. The genius of this system lies in its accessibility. You don't need to relocate to Okinawa, buy expensive supplements, or overhaul your lifestyle overnight. By integrating mindful eating, natural fasting, hydration, gentle movement, and nutrient-dense foods, anyone can begin activating autophagy and improving cellular health. It's a blend of simplicity, consistency, and cultural refinement, habits that have stood the test of time and scientific scrutiny alike. For viewers, the lesson is clear. Longevity isn't an elusive genetic lottery or a futuristic technology. It's a set of repeatable, daily choices. From a cup of green tea in the morning to mindful, portion-controlled meals, you can cultivate the cellular processes that make life longer, healthier, and more vibrant. And as Osumi's research demonstrates, the very same genes that regulate autophagy in yeast are present in human cells. Our biology is ready to respond to these practices. In the next part, we will dive deeper into the cellular mechanisms of aging, exploring how senescence, oxidative stress, telomere shortening, and lifestyle factors interact to determine how we age, and why activating autophagy is the most powerful tool in our biological toolkit. You'll see that aging is not an unavoidable decline, but a process we can influence every day, turning the science of cellular health into practical and actionable strategies for life.
Part 2. The cellular science of aging and repair. Aging is not just a number. It is a complex biological process happening at every moment within our cells. While society often presents it as an inevitable decline, modern science tells a far more empowering story. Aging can be influenced, slowed, and in some cases partially reversed through lifestyle, nutrition, and emerging therapies. At the heart of this process lies cellular senescence, the point at which cells lose their ability to divide, repair, and function efficiently. These retired cells accumulate over time, producing inflammatory molecules, crowding tissues, and disrupting the function of healthy cells around them. Imagine a factory where the workers suddenly stop doing their jobs but refuse to leave. The entire operation falters. In our bodies, this translates to chronic inflammation, weaker tissue regeneration, and a higher risk of diseases like diabetes, cardiovascular conditions, and neurodegeneration. The exciting discovery is that senescence is not permanent. Laboratory research has shown that aged cells can regain youthful function when supported correctly. Animal studies reveal that removing old, damaged cells or activating repair pathways can restore organ function, energy, and even cognition. These findings reveal a crucial truth. Aging is not random, and it can be influenced if we understand the cellular mechanisms at play. Another central aspect of aging lies in our genes. DNA is constantly challenged by environmental factors like UV radiation, pollution, and oxidative stress from metabolism. Over time, genetic mutations accumulate, compromising cellular efficiency. Telomeres, the protective caps at the ends of chromosomes, shorten with each cell division, limiting a cell's lifespan. When telomeres reach a critical length, cells enter senescence. Fascinatingly, certain species, from some fish to long-lived mammals, can regenerate their telomeres, maintaining cellular youth far longer than humans. Scientists are investigating ways to harness these regenerative capabilities for human longevity. Oxidative stress, another silent driver of aging, further accelerates cellular decline. Free radicals, unstable molecules produced during metabolism, damage proteins, DNA, and cellular structures, contributing to wrinkles, cognitive decline, and organ dysfunction. Antioxidants found in berries, leafy greens, nuts, and seeds neutralize these free radicals, supporting cellular repair and slowing age-related deterioration. When combined with regular exercise, quality sleep, and a nutrient-rich diet, these interventions create an internal environment where cells can thrive and repair themselves efficiently.
Yet genetics is only part of the story. Epigenetics, the study of how lifestyle and environment influence gene expression, highlights that we are not helplessly bound by our DNA. Diet, movement, stress management, and social engagement can switch on or switch off certain genes, modulating aging pathways. Blue zones, regions known for extreme longevity, such as Okinawa, Sardinia, and Ikaria, demonstrate this principle in action. Residents consistently combine plant-rich diets, daily physical activity, social support, purpose-driven living, and mindfulness practices, creating metabolic and genetic conditions that favor health and extended lifespan. The frontier of aging science is now moving toward reversal. Techniques like activating key longevity pathways, intermittent fasting, caloric restriction, and targeted nutrition have rejuvenated tissues in animals and extended lifespan. Early human studies are promising, showing improvements in metabolic health, inflammation reduction, and cellular repair. While fully reversing human aging remains experimental, the trajectory of research demonstrates that we can slow or mitigate the biological clock significantly with lifestyle interventions. Understanding these mechanisms transforms how we approach aging. No longer a passive fate, it becomes an active process shaped by our choices. Daily habits like hydration, mindful movement, nutrient-dense eating, and exposure to natural sunlight not only support overall health, but directly interact with cellular processes, optimizing repair, reducing inflammation, and maintaining vitality. In the next part, we will explore groundbreaking discoveries that allow scientists to influence the speed of aging, introducing concepts like age.The, cellular identity, and the activation of MTOR, AMPK, and Sirtuins pathways. You'll see how the science of cellular rejuvenation is bridging the gap between laboratory findings and practical strategies that anyone can apply to extend health span and vitality.
Part 3. Can we control the speed of aging? Revolutionary discoveries. Imagine if you could slow down your biological clock, not by a few months, but by decades. What once seemed like science fiction is now emerging as tangible science. Instead of passively accepting the signs of aging, research shows that we can actively influence the pace at which our bodies age, giving us the power to maintain vitality, cognitive function, and overall health well into advanced years. Groundbreaking work by scientists like Professor David Sinclair has unveiled that aging is not a predetermined fate. By understanding the intricate workings of our cells and the genetic pathways that regulate growth, repair, and maintenance, researchers are now manipulating these mechanisms to slow aging, rejuvenate tissues, and potentially extend healthy lifespan. At the core of these discoveries are three critical pathways: MTOR, AMPK, and Sirtuins. These act like genetic switches, controlling cell growth, energy management, and DNA repair, creating the foundation for targeted longevity interventions. MTOR, or mechanistic target of rapamycin, functions as a master growth regulator. While essential for development and tissue repair, overactivation accelerates cellular aging. Think of it like pressing a car's gas pedal too hard. The engine wears out faster. Animal studies demonstrate that inhibiting MTOR through strategies like caloric restriction or intermittent fasting slows aging, improves organ function, and increases lifespan. In essence, managing MTOR shifts the body from growth mode into repair mode, supporting cellular maintenance and longevity. AMPK acts as a cellular energy sensor. When energy levels drop during fasting or exercise, AMPK activates pathways that burn fat, improve insulin sensitivity, and enhance mitochondrial function. It also triggers autophagy, the cell's internal cleanup process, recycling damaged proteins and organelles. This cellular housekeeping prevents the buildup of harmful waste, reduces inflammation, and supports long-term resilience. High-intensity interval training, or HIIT, and intermittent fasting are proven ways to activate AMPK, enhancing metabolic health and energy efficiency. Sirtuins, a family of proteins, serve as guardians of our DNA, protecting and repairing it while maintaining cellular balance. Activated by fasting, exercise, and stress, sirtuins regulate mitochondrial function, DNA repair, and metabolic equilibrium. NAD+, a crucial coenzyme, fuels these proteins, but its levels naturally decline with age, reducing repair efficiency. Early research suggests that boosting NAD+ through dietary precursors, supplements, or lifestyle practices can restore some youthful cellular functions, slow aging, and enhance overall vitality. Animal experiments offer remarkable proof of concept. By activating MTOR, AMPK, and Sirtuins pathways, scientists have reversed age-related decline in mice, restoring organ function, cognitive abilities, and physical performance. While human studies are still emerging, early interventions like NAD+ supplementation, intermittent fasting, and targeted lifestyle changes show significant promise. These advances suggest a future where aging is a manageable, modifiable process rather than an inevitable decline. The practical applications of these discoveries are already within reach. Lifestyle interventions, consistent physical activity, nutrient-dense diets, stress management, and strategic fasting interact with these genetic pathways, promoting cellular repair, reducing inflammation, and preserving vitality. This demonstrates a profound truth. While we cannot stop the passage of time, we can influence the biological processes that determine how our bodies age. The benefits extend beyond longevity. Health span, the period of life spent free from disease, mentally sharp, and physically active, can also be increased. Supporting cellular repair and metabolic balance translates into higher energy, improved cognition, and enhanced physical performance even in advanced age. Aging is no longer just about adding years, it's about maximizing the quality of those years. In the next part, we will dive deep into the key genetic pathways that regulate longevity, MTOR, AMPK, and Sirtuins, and reveal how daily choices like diet, exercise, fasting, and stress management can influence these pathways to extend both lifespan and health span. You'll discover how the intersection of science and lifestyle empower anyone to live longer, healthier, and more vibrant lives.
Autophagy is the body's way of cleaning out damaged cells in order to
Part 4.
regenerate new organs.
Key genetic pathways for longevity. MTOR, AMPK, and Sirtuins. When it comes to aging, much of the public conversation focuses on external factors: diet, exercise, sleep, and lifestyle habits. While these are undeniably important, the true drivers of how we age reside in our genes. At the heart of longevity science lie three powerful genetic pathways identified by Professor David Sinclair and his colleagues: MTOR, AMPK, and Sirtuins. Understanding these pathways gives us actionable insight into how small daily choices can influence cellular health, optimize repair, and extend both lifespan and health span. MTOR, or mechanistic target of rapamycin, serves as a master growth switch. It responds to nutrients, especially protein, signaling cells to divide, grow, and generate energy. This mechanism is crucial for development and tissue repair. However, when MTOR is overactivated, such as through chronic overnutrition or high-protein diets, cellular aging accelerates. Imagine an engine running at full speed non-stop. Eventually, wear and tear sets in, leading to faster cellular decay and age-related diseases like cancer, cardiovascular disease, and neurodegeneration. The encouraging news is that MTOR can be moderated. Practices like caloric restriction, intermittent fasting, and balanced protein intake can inhibit MTOR, shifting the body from growth mode to repair mode. In animal studies, this approach improved organ function, slowed cellular decline, and increased lifespan, illustrating the profound impact of modulating this pathway. AMPK functions as the cell's energy sensor. When energy drops during exercise or fasting, AMPK activates metabolic pathways that enhance fat burning, improve insulin sensitivity, and stimulate mitochondrial function, the powerhouses of the cell. Additionally, AMPK triggers autophagy, a natural cellular cleanup process that removes damaged organelles and proteins. This process maintains cellular efficiency, reduces inflammation, and prevents premature aging. Scientific evidence demonstrates that activating AMPK through consistent exercise, especially HIIT, and intermittent fasting enhances metabolic resilience, reduces the risk of chronic disease, and supports both energy and cognitive performance. Sirtuins are proteins that protect DNA, maintain cellular integrity, and regulate metabolism. As we age, DNA damage accumulates due to environmental stressors, free radicals, and normal cellular wear and tear. Sirtuins act as guardians, repairing damaged DNA, supporting mitochondrial function, and preserving overall cellular health. Their activity can be stimulated by lifestyle factors like fasting, exercise, and controlled stress exposure. NAD+, a key coenzyme, powers sirtuins, but its levels naturally decline with age, reducing the cell's repair capacity. Emerging research suggests that boosting NAD+ through supplements, diet, or lifestyle interventions can partially restore youthful cellular functions, slow aging, and enhance overall metabolic health. What makes these pathways particularly compelling is the intersection of genes and lifestyle. They are not rigid or immutable. Daily choices can significantly influence their activity. Exercise, mindful nutrition, quality sleep, and stress management work synergistically to activate MTOR, AMPK, and sirtuins naturally. This empowers anyone to leverage their biology through consistent, informed actions, no expensive medications or advanced technology required. By understanding and harnessing these pathways, we gain control over the biology of aging. Aging is no longer a passive, uncontrollable process. It becomes a system we can influence. Small, consistent interventions like mindful movement, fasting, or intentional stress reduction accumulate over time, resulting in increased energy, enhanced mental clarity, and greater resilience. In the next part, we will explore practical, science-backed morning habits and lifestyle strategies that anyone can adopt to slow aging, from hydration and sunlight exposure to stretching, nutrition, and mindfulness. These small but consistent actions activate key longevity pathways and provide tangible improvements in daily health and vitality.
Part 5. Practical morning habits to slow aging. Understanding the key genetic pathways of longevity, MTOR, AMPK, and sirtuins, is only part of the equation. The real power comes from putting this science into practice, incorporating habits that activate these pathways naturally in daily life. The morning, in particular, sets the tone for cellular health, energy levels, and cognitive clarity throughout the day. Small, intentional actions done consistently can have profound effects on aging, metabolism, and overall well-being. The first habit is deceptively simple: hydration immediately upon waking. Overnight, the body loses water through respiration, sweat, and natural metabolic processes. Drinking a large glass of water first thing in the morning replenishes lost fluids, kickstarts metabolism, improves circulation, lubricates joints, and supports cognitive function. Research from Johns Hopkins Medicine confirms that even mild dehydration in adults over 65 impairs cognitive performance, increases inflammation, and accelerates cellular aging. Making hydration a priority lays a foundation for energy, mental clarity, and daily repair at the cellular level. The second habit is early morning sunlight exposure. Just 15 to 20 minutes of sunlight on the skin triggers vitamin D synthesis, enhances mood, boosts immunity, and aligns circadian rhythms. For older adults who often produce less vitamin D naturally, this simple practice counteracts fatigue, low mood, and muscle weakness. Scientific studies underscore that consistent morning sunlight exposure contributes to long-term bone health, hormonal balance, and even cognitive function.
For those living in urban environments, sitting near a sunny window or walking in a quiet park can provide similar benefits. The third habit involves gentle, mindful stretching to awaken the body. Spending 5 to 10 minutes stretching arms, shoulders, neck, legs, hips, and spine helps restore mobility, reduce stiffness, and enhance circulation. Harvard research shows that morning stretching activates the nervous system, improves balance, and lowers the risk of falls in older adults. Beyond physical benefits, stretching releases endorphins, improving mood and establishing a positive mental tone for the day ahead. This small investment in movement translates into tangible longevity benefits when practiced consistently. A fourth habit is consuming a protein-rich breakfast. Protein supports muscle maintenance, cognitive function, and blood sugar balance. Swapping processed carbs or sugar-heavy foods for eggs, yogurt, lean meats, or seeds stabilizes energy levels and nourishes cells for optimal repair. Research from the American Journal of Clinical Nutrition highlights that protein-rich morning meals improve lean mass retention, strength, and mental clarity, especially in aging adults. Simple swaps like replacing cereal with eggs or adding nuts to yogurt can make a measurable difference. The fifth habit focuses on the mind. Morning meditation with brainwave frequency audio. Theta brainwave activation through guided audio, focused breathing, or meditation reduces stress, enhances clarity, balances emotions, and improves decision-making. Just 5 to 7 minutes daily can help regulate blood pressure, improve sleep quality, and prime the body and mind for optimal performance. Studies from Harvard and Columbia University show that specific sound frequencies and meditative practices activate neural networks, boosting memory, creativity, and emotional resilience. Consistency is the key. Transformation does not occur overnight. Starting with one habit, hydration, sunlight, or stretching, and gradually layering the others allows the body and mind to adjust, creating sustainable routines that reinforce longevity pathways. Over weeks and months, these small, deliberate actions compound, restoring energy, vitality, and autonomy even in later years. The essence of longevity science lies in these incremental, intentional choices. By integrating hydration, sunlight exposure, mindful movement, protein-rich nutrition, and focused meditation, we can influence our genes, optimize cellular function, and slow aging naturally. This is not a quick fix or a magic pill. It is a lifestyle of awareness, presence, and commitment, one deliberate action at a time. In the next part, we will explore the future of anti-aging, examining innovations in personalized medicine, gene editing, regenerative therapies, and AI-driven interventions, revealing how science is making healthy, vibrant longevity more attainable than ever.
So based on your genetic markers, we're seeing some...
Part 6. The future of anti-aging and personalized wellness. The frontier of anti-aging science is no longer a distant dream. It is rapidly becoming reality. Innovations in genetics, regenerative medicine, AI-driven health analysis, and personalized interventions are transforming the way we approach longevity. The goal is no longer simply to add years to life, but to enhance health span, ensuring those years are lived with energy, clarity, and vitality. One of the most promising avenues is personalized medicine. Unlike generic treatments, personalized approaches tailor interventions to an individual's genetic makeup, lifestyle, and environment. Advances in DNA testing and genetic screening now allow doctors to identify age-related risks and craft specific strategies. These strategies can include dietary adjustments, exercise plans, supplements, sleep optimization, and stress management techniques, all designed to protect cellular health and activate longevity pathways. By customizing interventions, we can prevent age-related diseases before they appear, transforming aging from a reactive process into a proactive one. Gene editing technologies such as CRISPR hold transformative potential. Scientists are exploring ways to correct mutations associated with cellular senescence, telomere shortening, and age-related diseases like Alzheimer's, Parkinson's, and cardiovascular conditions. By targeting these fundamental mechanisms, gene editing could one day prevent or even reverse aspects of cellular aging, significantly extending both lifespan and health span. While still in early clinical trials, the promise is immense. Interventions at the DNA level could complement lifestyle-based longevity strategies, offering a dual approach to healthy aging. Regenerative medicine is another groundbreaking field. Stem cell therapies, tissue engineering, and biomaterials are being used to repair or replace damaged tissues and organs. Early studies show that stem cells can rejuvenate aging tissues, stimulate healthy cell growth, and restore organ function. Even cosmetic regenerative applications, such as stem cell-based skin rejuvenation, are becoming more accessible. This technology has the potential to reverse both internal and external signs of aging, making vitality and functional independence achievable well into later life. Artificial intelligence is revolutionizing anti-aging research by analyzing vast datasets of genetic, epigenetic, and lifestyle information. Machine learning identifies patterns, predicts aging trajectories, and designs personalized interventions faster than ever before. AI also accelerates drug discovery, pinpointing compounds that target specific aging pathways. The combination of AI and personalized medicine allows interventions to be tailored with unprecedented precision, ensuring maximum efficacy and extending health span and maintaining cellular function. These technological advancements come with ethical considerations. Accessibility, equity, and societal implications must be carefully addressed to prevent widening health disparities. Responsible use of anti-aging technologies will be critical to ensure the benefits reach everyone, not just a privileged few. Alongside ethics, a holistic approach remains essential. Science and lifestyle must work together to achieve optimal health. Even as cutting-edge therapies emerge, foundational lifestyle practices remain irreplaceable. Hydration, sunlight exposure, movement, stress management, and balanced nutrition continue to be the cornerstones of longevity. Integrating these evidence-based habits with futuristic interventions amplifies their effectiveness, creating a synergy between biology, behavior, and technology. The promise of the future is not only longer life, but better life. Years filled with clarity, energy, and independence. Professor David Sinclair and other leading scientists inspire optimism. While we may not yet fully reverse aging, we already possess the tools to slow its progression, repair cellular damage, and enhance resilience. By combining scientific understanding, practical lifestyle habits, and emerging technologies, we can redefine what it means to age gracefully. The message is clear. Longevity is within reach for anyone willing to embrace science-backed strategies, intentional living, and mindful self-care. Every small, consistent choice today builds the foundation for vibrant health tomorrow. The era of empowered, evidence-based, purposeful aging is here, and it is accessible to all who choose to step into it.